Hi guys, in this video I am going to perform laboratory activity number 1 about complex numbers using the MATLAB software. So first, I created a new script, which in this case I had already done. So, and then save it as elevado underscore ECE224 lab 1. After that, I proceed to part B on conversion of complex numbers and type the given following lines of codes in the MATLAB script. In this code, I had defined z equal to 3.12 minus j times the square root of 3. So this is our complex number in rectangular form. And then I have defined that a is equal to the real part of z, in this case 3.12, and b is the imaginary part of z, in this case the negative square root of 3. Okay, so these two lines of codes here is our formula, and then the first line is the formula to find the modulus of a, and then the second line is the formula to find theta. Okay, then lastly, this last line of code will show the output in polar form. So by clicking run, we have our answer 3.5685 angle negative 29.0366 degrees. Proceeding to step 3, this time I will use the car2pol function to find the polar form of the previous complex number. So I will hide the previous codes by clicking the percentage symbol, this one here, or by simply using the control R so that it won't execute when I will run the new code. Okay, so in this case, let us hide this, and then let us type, I will type the new code. So this is the new code. The goal here is to find the same, to find the polar form, but in this case using the car2pol function. So this is the formula, and this line will show the output in polar form. So by clicking run, I've got an answer of 3.5685 minus angle negative 29.0366 degrees, which is the same with the previous result. Next is step 4, and this time I will do the reverse, wherein using the same the values for the polar form, wherein we have a modulus of 3.5685 and a theta of negative 29.0366. Okay, I will convert it back to its rectangular form. So by writing the codes, so this is the code. First, I defined the values for a and theta equal to the value of the polar form, and then this part here are the formulas necessary for finding the complex number in rectangular form, and then lastly, the last line of code will show the output in rectangular form. So by clicking run, I've got 3.12 minus 1.732 I. So, and by the way, in electronics and electrical engineering, J is used instead of I because in that field I is used for current. So to avoid confusion, the electrical and electronics engineers use the letter J. This answer is the same with our original problem, 3.12 minus j square root of j times square root of negative 3, because negative 1.732 is equal to negative the square root of 3. Proceeding to step 6, I will use another code to solve for the rectangular form using the same set of values for a and theta. So typing the codes, so this is the new code. So the same set of values for A and theta, and then this will be the formulas, and this part will output the answer in rectangular form. So by clicking run, oops, sorry, I've got an error. Okay, by clicking run again, so there. So we've got 3.12 minus 1.732i, which was the same with our previous result of 3.12 minus 1.732i. So either of the two functions, we will get the same results. So next step is step number 7, wherein I will repeat steps 1 to 3 with example given on item number 1, page 3. So let me go back and hide these codes. Okay, let's go back to the top. So this time we will have 3 plus J4. So let me replace this equation, 3 plus J4, like that, and then unhide all these codes. Okay, so by clicking run, we will have the polar form. So the polar form is 5 angle 53.1301 degrees. So this is our answer. Now let's try the Cartopole function. So let's hide the previous codes and then unhide the second codes. Okay, so we have this, and then let's run it again. So in this case, we also have 5 angle 53.1301 degrees. So either of the two codes or functions, we will still have the same results. Next, let me proceed to step number 8, wherein I will repeat the step 4 to 6 with example given on item number 2, page 3. Okay, so and the problem, first let me hide the previous equations or the codes, and then let us proceed to here. So in this case we have the value, in this case we have the polar form 13 angle 67.38. So let me replace this, the modulus of A is 13 and the theta as 67.38. Okay, now let us unhide in order to find the answer. Okay, then we have these codes, these lines of codes, and then by clicking run, so I've got the rectangular form 5.003 plus 12i, or in the laboratory activity it is 5 plus j12. Okay, now this is the first function. How about trying the second function? So I will hide this and then unhide the second function, and let's see if they will have the same results. Then run it again. Okay, so there, once I click run, it still showed the same answer, wherein I have 5.003 plus 12i. Okay, which is the same from the previous function or the codes, which is 5 plus 5.003 plus 12i. Okay, so moving on to part C, on operations on complex numbers. So given the complex numbers z1 and z2, find the sum and difference of z1 and z2. Okay, so let me type the codes. So this is the code. First, I defined values for z1 and z2. Then second, this part here is the for the formula. And then lastly, the last two lines of codes will show the output for the sum and the difference. So by clicking run, I've got an answer of, for the sum, negative 0.9 plus 5.64i, and for the difference, negative 3.7 plus 7.36i. Next is the step 3. So given the same complex numbers above, solve for the product and the quotient of the two complex numbers, which is z1 and z2. So first, let me type the codes. So this is the code. We have the same set of z1 and z2, and then this part here will be the formula for the product and the quotient of z1 and z2, and then lastly the two lines of codes will show the results for the product and the quotient. So by clicking the run button, so I've got an answer of, for the product, 2.37 plus 11.0 is 078i, and for the quotient, negative 3.2634 plus 2.6382i. Okay, so that's all for this laboratory activity number 1.